in some second we start. Okay. Oh, wonderful. We have people from Texas, Dan too. Okay, we are ready on YouTube, Dan. Please, if you can introduce yourself for all our people. We can start. We have 45 minutes and 50 minutes of question. So it's your time. Thank you, Dan.
Thank you, Hernan. Again, my name is Dan Miller. Welcome everyone from around the world. Good day from Nebraska in the middle of the USA. Understand that may be evening or even the middle of the night for some of you, but we appreciate you being here and taking time out of your day to be here with us to talk about the hazard of lithium-ion battery fires and thermal runaway and the off-gassing and all of the hazards that go with it, as well as the solution. So my background is in the fire service for over 40 years. I'm a retired fire chief and battalion chief also in the city of Omaha, Nebraska, and retired training chief. Also got decades in the electronics field and DC electronics, hazardous materials response, and a few other things along the way. So today, what we're going to be working on, obviously, the lithium-ion battery. We want to hear what brought you to this webinar. We want to hear why you are joining us. We know it's about lithium-ion batteries, but are you looking for a solution? Did you hear about us somewhere? Do you have a specific hazard that you are trying to overcome with automotive electronics, consumer electronics, recycling, manufacturing? We'd like to hear why you're joining us today. That helps us fine-tune our future deliveries just for you, different groups. Today, we're going to have a question and answer session near the end of the presentation. So be sure and put your questions in the Q&A. There's a button right next to your chat button for Q&A. Questions and answers here in the US that's what we use that acronym for. If you have questions that come up, be sure to ask them so that we know that that's what's on your mind. And if we can help you answer those questions, we sure will. If you would like to receive a copy of today's presentation, as Hernan said, it's going to be available via YouTube, a YouTube link that will also be sent to you. Hopefully you registered for the course so you'll get credit for training, as well as an email with a link to the material. Before we get started today, I'd like to wish a happy birthday to our president, the president of Hazard Control Technologies, Mike Reiner. It's his birthday today. Happy birthday, Mike. A little bit about HCT. HCT was started clear back in 1997, clear back in the 1900s, long time ago. Been in business for over 25 years with our primary product, F500 encapsulator agent, which is a water additive agent. And we'll talk about how F500 works with water molecules and water droplets to mitigate fire, spills, and vapors. We've got a worldwide distribution network, and F500 by itself helps the world create a more sustainable future from fire, from combustion, from vapor producing processes. And because it's a water additive, it's very scalable. It's also protective of the quality of our water and soils and our environment. So we're going to talk a little bit about how that works and why it's helpful. So our primary mission today is to talk about lithium-ion battery fires. Lithium-ion batteries are really appearing everywhere in our world, from material handling equipment to fleet vehicles to passenger vehicles, privately owned and operated, over-the-road trucks, heavy equipment, consumer electronics, the hand tools that most of us use somewhere along the line, either at home or at work. They're just everywhere. They're part of our environment now, and we need to learn how to overcome the extraordinary hazard that they present under certain circumstances. So talk about a little bit about how that occurs. There are several types of lithium-ion batteries out there, but the consequences are largely the same between the different battery chemistries and types. So where are lithium-ion batteries found? Well, today in aerospace and aviation, really taking off, no pun intended, but a lot of ground support equipment for aerospace and aviation is or has already moved to lithium-ion battery power. And we're looking at actually powering the aircraft themselves with lithium-ion batteries in the near future. Carrying lithium-ion batteries on board of those vehicles, whether you're going onto a plane or maybe it's a cargo plane and they're being shipped somewhere, that's a hazard as well as cargo. The automotive industry, huge. Every segment of the automotive industry is developing with lithium-ion batteries. And it doesn't matter if it's a riding lawnmower or an over-the-road truck or heavy equipment or anywhere in between. Even mining equipment is using lithium-ion batteries nowadays. So every segment of the automotive industry is developing with lithium-ion batteries. You go to your hardware store or your big box home improvement store, you're likely seeing a lot of lawn equipment in there now that's lithium-ion battery powered, as well as, leaf blowers, weed trimmers, you name it. Anything you can think of, you can buy with a battery. Energy storage. Energy storage is being used to stabilize the grid. So the grid has natural fluctuations as the load changes throughout the day, and sunlight and wind change, especially if we're going with renewable energy. Those have fluctuations. So what battery energy storage systems do is they store the energy during the high generation times, and then when that power can't be generated to stabilize the load, the energy comes back out of the energy storage system onto the grid, gets turned into a sine wave, and gets used as alternating current to power everything that we do. So it helps stabilize the grid, store some energy. For example, when it's dark out and it's a solar field, or it's not windy out in a wind generation area, then the battery energy storage system stores that. In the area where I live, they're doing a lot of natural gas energy generation right now to stabilize the grid for large data centers. And a lot of battery energy storage systems goes hand in hand with that. We're also seeing those in buildings. So anywhere where data is being stored now, these large data centers, they're converting from lead acid batteries to lithium-ion battery storage over time. So making sure there's fire protection in place in those facilities is very, very important, because that's where our most important data is stored. Personal devices and electronics, the maritime industry, not only powering the craft themselves, but the cargo, the container ships going back and forth carrying lithium-ion battery from where they're manufactured to where they are going to be used. And then in that cradle to grave life cycle, we're looking at the manufacturing of the batteries themselves, their inclusion or integration into products, the life cycle of the battery, and then they get recycled and sent somewhere. So it's that cradle to grave life cycle that we have to worry about lithium-ion batteries for. And what we find nowadays a lot in the recycling industry is lithium-ion batteries get improperly discarded, or at least somewhat abused during the recycling process, and they can get crushed or creased or anything like that, and it causes pretty much an instant fire. So how does the lithium-ion battery work? So you've got an anode and a cathode. The The cathode is what we call the positive terminal of the battery. The anode is the negative terminal. That's the one on the left with the O over the top of it. But you've got lithium ions move from the negative electrode to the positive electrode during the discharge, and then back when they're charging. And it does so across a membrane. And there's layers of foil in there, and copper, and the lithiated salts, and so forth, to make this chemical, the electrochemical process, work back and forth over time. But what happens in many cases, if there's some kind of a trauma to the battery, you have those different layers of metal coming together and creating an internal short circuit. Well, batteries normally generate heat when they're charging or discharging, but they generate an extreme amount of heat if you somehow penetrate that membrane and bring the anode and the cathode together into an internal short circuit. That can happen due to dendrites inside of the battery, bad battery chemistry, or use over time. Can also occur as a result of sudden trauma to the battery. So overcharging or over discharging, fast discharging of the battery can cause that membrane to break down as well. And then you have an internal short circuit. So the demand on the lithium-ion battery can create heating as well. Anytime that you have intentional or unintentional misapplication or misuse of the battery, is susceptible to what we call thermal runaway. So we look at lithium-ion batteries and the demand overall being everywhere over the surface of the earth really now, and being in use in every industry and in every home. We've got a sizable but growing problem. There's a lot of diverse classes. There's at least, five or six different popular types or chemistries of battery, like lithium iron phosphate, lithium magnesium oxide, lithium cobalt oxide. There's several of them. So each one of those, when they do break down and go into thermal runaway, contains a different set of off gases. But all of the off gases are toxic, and all of the off gases are flammable. So it doesn't really matter which battery chemistry is being used if it's putting off flammable and toxic gases and creating a high energy thermal runaway. We've got a potential for a big life-threatening and property-threatening problem. How can the fire start? Short circuiting. Lithium-ion batteries can be unstable from their manufacturer, or misuse in the field, or misapplication to what they're being used for. Trauma to the batteries, drops, collisions, piercing, creasing, getting crushed by a material handling equipment in a recycling facility or some kind of machinery. Anything can happen. Overcharging or over discharging, in other words, charging too fast or discharging too fast, creates too much heat for the battery pack to withstand, and you have a potential for thermal runaway. And then extreme temperatures. Extreme heat can cause the batteries to be closer to their maximum operating temperature from the beginning. Extreme cold causes those ions not to move very well inside of the battery. And sometimes we try to force a charge or force a discharge, and that can cause a problem with the battery as well, at least shorten its life. So this occurred in Lakewood, New Jersey.
On the inside, it doesn't look like it at this point. It's okay. Can you see the ceiling? Because I definitely have fire that envision a conflict.
In 2023, this was at a shipping terminal for UPS, obviously. What happened was one of their trucks backed up to the dock, to the loading dock, and it had some batteries in there that were being shipped off for recycling. Well, for whatever reason, they caught fire. They caught part of the terminal on fire then. Much larger fire occurred as a result. Fire department showed up, now they get to deal with the results. So luckily, a couple of firefighters that knew how to operate a truck were able to pull some of the trucks away. But in a case like this, you don't only have an isolated vehicle fire, you've got an entire terminal on fire now, and whatever's in that terminal for ordinary or extraordinary combustibles. So there's always exposures to lithium-ion battery fires. And one of the things we like to point out and focus on as hazard control technologies is we always have to be ready to save lives, save infrastructure, and we have to be ready to, if water flows, so does F500, because we don't get to control as firefighters or even fire protection people in many cases what's burning and what the consequences are. We have to be ready to save lives. We have to be ready for the worst consequences. And we'll talk about how F500 enhances those, enhances the firefighters' effectiveness on all fuels, but as well as lithium-ion batteries. So they had a struggle on their hands when they show up here. Pretty large and growing fire, heavy smoke. Smoke is banking down towards the ground, limiting visibility. As fire departments and firefighters, we don't get to choose when we get the call or really what the circumstances are when we show up. We just have to deal with it when we get there. So F500 gives you the maximum effectiveness for your firefighting solution and for your firefighters to save lives and save property. Well, how efficient is water at cooling? Well, it's pretty inefficient actually. Less than 10% of water typically provides cooling. The rest of it runs off without a temperature change. What does cool turns to steam, and steam is actually invisible and burns your skin, scalds your lungs clear down to the alveoli, which exchange the oxygen and carbon dioxide in your body, and very, very harmful. With lithium-ion batteries, we have often a reignition of the batteries after they've been cooled with plain water because it has a high surface tension and doesn't get down into those base materials inside of that jelly roll or those layers inside of a flat aspect battery. And it doesn't neutralize the hydrocarbon lithium material. Excuse me, the hydrocarbon electrolyte material. Water has minimal toxin reduction. So whether we're talking the vapor space as we're applying a water stream, it may be pushing those toxins around. We're talking the runoff, it may dilute them, but it doesn't really do anything else to reduce the overall toxicity or combustibility of those gases. Overall, water has a pretty low efficiency, especially when it comes to lithium-ion batteries. So F500 encapsulator agent is the agent that HCT has manufactured since 1997 under ISO 9001 certification. The same product now as it was then. It's got a 15-year shelf life, and it has some very unique characteristics that make it really, really effective on lithium-ion batteries in the over 15 years of testing that we have in place. Now we're looking at 16 years because recently in the last month or two, even in the last few days, we've had more testing that was successful. So F500 rapidly reduces the temperature inside of the batteries because it's able to penetrate very, very well. Got a high molecular weight, a lower surface tension than water, and it coats each water droplet, as you see in the image in the center of this slide, with a coating of F500 molecules. The heads of those molecules stick in, the tails stick out, and the heat is readily absorbed to the inside of that water droplet into those spherical micelles inside through a process we call transference. That water droplet is extremely packed full of those spherical micelles. There's millions and millions of them in there absorbing heat all the time. The water droplet is allowed to be much smaller than a plain water droplet because of the surfactant And it literally can penetrate those batteries where they're coming apart at the seams and get in there to the flammable electrolyte and neutralize that electrolyte, as well as cool at least 10 times as well as plain water does at 3% solution. It prevents reignition because it encapsulates those flammable corrosive electrolytes at the core of the battery. It reduces the toxins. We'll talk about how that works in a little bit, but the encapsulation process encapsulates the toxins inside of the spherical micelles. The overall efficiency of F500 is almost 100% effective. What applies reduces heat. You get some F500 water vapor off of it, but it clears up the atmosphere very, very quickly, reducing toxins and enabling escape. So when every second counts, copious water hasn't been enough. There's been study after study, and people still say all you need is plain water. But plain water's been proven to not be effective over and over again. In July of 2024, there was a truck that caught on fire in Nevada that took days to put out and over 50,000 gallons of plain water. We're to talk to you about an incident that occurred early yesterday morning in Nevada, where the opposite occurred. F500 was used and much less water was used. We also need to be able to save lives. Fire departments, we respond to save lives. If we're not in a position to save lives, we need to rethink what we're doing. F500 puts you back in a position to save lives at an EV fire or a lithium-ion battery fire. So F500 helps you mitigate the risk. This next little video shows you how the F500 water molecule, water droplet forms with the F500 molecules on the surface and inside, and some of their impacts.
Encapsulator technology, the next generation of fire and hazard mitigation. First, we start with a simplified version of a single encapsulator agent molecule consisting of a hydrophilic polar head which loves water, dissolves in water, and a hydrophobic nonpolar tail which fears water and will do anything to get away from water. Once the EA molecules enter the water, they instantaneously and automatically orient with the nonpolar tails inward and the polar heads outward, forming millions of spherical micelles. Micelles travel towards and exit the nozzles, forming EA droplets. Micelles nearest to the surface of each droplet automatically break apart. The nonpolar tails orient outside the droplet with polar heads on the surface, forming an EA skin on the surface of every droplet. In addition to the EA skin, there are millions of molecular spherical micelles within each droplet.
So that's a really simplified version. We have some really good Titanic background music to go with it. So what occurs as those water droplets are flying towards the fire, whether it's coming from a fire hose or a sprinkler system, is that they're encapsulating hydrocarbons out of the atmosphere, improving visibility. They're also, because of their high molecular weight, interrupting the creation of soot and smoke by interrupting the coalescence of free radicals. When free radicals come together off of complete combustion, smoke and soot are formed. In that smoke and soot, of course, are the things that obscure visibility, make the fire grow and expand into other compartments, and cause firefighters cancer, cause victims to suffer from smoke inhalation. So F500, as it's coming out of a sprinkler system, a deluge system, a firefighter's hose, is capturing and eliminating that smoke plume from occurring that would otherwise threaten life. So the other thing that it's doing is it's penetrating materials very, very well when it hits the surface of lithium-ion batteries, for example, in cells, it's going to penetrate, it's going to soak in, and it's going to neutralize the flammable electrolyte very, very quickly, just like it neutralizes flammable liquids very, very quickly. And it's extremely resilient under that high heat of those lithium-ion batteries to be persistent and to stay there and to keep cooling and not to vaporize really, really quickly like water does and just go away. This is very persistent. It stays around for just long enough to cool and vaporize at a little bit of a higher temperature, but by then more is already impacting. It just cools really, really well. At 1%, it cools 4 to 6 times greater than plain water. At 3%, it's 10 plus times greater than plain water. And we have some different rates that we use on different materials. Lithium-ion batteries is 3%. So if you're in the fire protection world, 3%. If you're in the firefighting world, it's 3%. So the benefits of the encapsulator agent or encapsulation, as we talked about, the carbons and hydrocarbons getting locked up inside of those spherical micelles become rendered neutral, whether they're airborne or liquid-borne or in some kind of a slurry. If they're small enough to get encapsulated by a spherical micelle and broken up into the hydrocarbon chains, then they'll get encapsulated and rendered neutral. Rapidly reduces heat, rapid calorie absorption, long-term stable burn back resistance because it's more persistent than water, and it's soaking in and penetrating much, much better than a plain water would. And this is a good time to say F500 is not foam. It's the exact opposite of foam. It's a penetrating type of water additive, whereas foam just sits on top. All right, whereas I like to say that whereas foam is the whipped cream on top of your coffee drink, F500 is the creamer that goes in your coffee. It mixes in. Free radical interruption, again, that rapid energy absorption, high molecular weight, very persistent, and then blocks the creation of smoke and soot. So it guards the ability of people to escape, firefighters to escape. If you're talking fire protection, it enables safe egress.
This is a lithium-ion battery test provided at the request of an international car manufacturer. Speed of extinguishment was the primary requirement, and secondary was cooling. The batteries have been overcharged.
I just want to point something out really quickly. You're going to see some different gases come out of this EV battery module. Some of them are heavier than air and hug the ground. Other ones go vertical and float higher. We know about hydrogen fluoride as one of the heavier than air gases. Carbon monoxide about the same. Pure hydrogen is going to go up, but we've got a mixture of a lot of different gases there. F500 is effective at reducing all of those in the atmospheric concentration as you're applying it. So another chance to point out when lithium-ion battery fires occur, oftentimes you get a lot of off-gassing before you have flaming combustion. F500 is one of the only products that I know of that can prevent this incident from going further. We can detect this early. We can start deluging it very, very quickly and prevent it from going into full flaming thermal runaway. What happens if we don't prevent it from doing that? It can go straight to explosion because you have that vapor cloud concentration that you need that's optimal for explosion in a very, very short period of time in an enclosed area.
To the point where they ignite. From initial conflagration, the temperature is around 400 degrees Celsius.
You'll see that cyclical behavior as it's going from cell to cell to cell and making more cells go into thermal runaway
When the explosion
by a process
happens,
that we
the
call
temperature has more than
propagation.
doubled to over
Propagating from
800
one
degrees
cell to the
Celsius.
next. So no matter, you know, the environment that you're fighting
In order to understand
lithium-ion
what would
batteries
happen
in,
after the initial explosion,
you're going to
the
likely
batteries were
have
allowed
some
to
of that
burn for a
cyclical
further 5
behavior
minutes.
occurring. The jetting of the flames, then will settle back down, and then you'll get some more. And then the ordinary combustibles that are surrounding them are
From the
also
moment
catching fire.
F500 is applied to the fire, the flames are out within 3 to 4 seconds.
Notice the absence of smoke. That's just F500 water vapor. No smoke left.
The temperature very quickly drops down from over 400 degrees Celsius and was recorded at 300, 200, 100 degrees Celsius, and within 3 minutes of the application of F500 was recorded at 40 degrees Celsius. And a further minute after that, the batteries were able to be handled.
One of the things that often comes up as we discuss lithium-ion batteries is reignition. So reignition can occur. It doesn't often occur after we apply F500, but if the batteries are mishandled in any way, shape, or form after they're extinguished, they can have a new or reoccurring short circuit internally and go right back into thermal runaway. So mishandling post-fire is one of the big reasons for reignition.
This is a lithium-ion battery test.
Video. There we go. So this was an experiment and testing done up in Seattle, Washington area, and took 3 Priuses, loaded them up with some lithium-ion batteries in the rear compartment area where they would normally be in those, and then did some different fire attacks on those. So we're gonna see some of the results of those.
Putting the Prius fire out pretty fast.
So that nozzle that firefighter has is one of our 20 gallon per minute or 75 liter per minute TKO nozzles. And there's F500 concentrate in there. He's got it dialed up to 3%, just a typical firefighting hand line. Can put out a lot of fire with it. You know, there are some different tactical limitations to that nozzle, but it is very effective, and it shows how F500 can be very effective on a pretty sizable fire with a lot of heat release rate at a much lower gallon per minute rate or volume than plain water.
Looks like it's out. Got fast.
In all of those experiments, and there were a few of them, they never had any trouble with reignition, put the fires out very, very quickly. And when we're talking about firefighting, if our goal needs to be able to arrive on scene, put the fire out quickly, get it under control quickly in order to save lives, because that's our ultimate purpose. So lithium-ion batteries, obviously a flammability hazard. That flammable corrosive electrolyte that's inside of those batteries, because of the different misuses, misapplications, or trauma, it goes from cell to cell to cell. It propagates, the thermal runaway does, and F500 is able to get in there, penetrate not only between the batteries in the battery pack, but into the layers inside of the batteries especially where the batteries have started to come apart due to overheating. Gets in, penetrates quickly, cools everything down much more quickly than plain water. It encapsulates those off gases that are hazardous and stops the incident very, very quickly, typically within just a few seconds if you're applying it appropriately and with enough volume. F500 ceases the production of explosive off gases. So again, we talked about the methane, the carbon dioxide, the hydrogen fluoride, excuse me, carbon monoxide, and methane and hydrogen and things like that all come off of these lithium-ion batteries. F500 encapsulates all of those harmful gases and prevents the creation of new ones from forming as you apply it. So it's a very fast-acting water additive. Reduces the toxicity of the smoke and the runoff simultaneously. So it's a dual benefit to people and the environment. So this test done at Port Authority of New York and New Jersey using an e-bike battery.
Oh, okay.
So this is an e-bike battery in a cage.
Okay.
Being heated up by a turkey fryer beneath it. They warm it up, put it into thermal runaway, and once it gets into thermal runaway, they're going to attack it with F500 in one of our pressurized water can extinguishers. So it's just a 2.5 gallon extinguisher, excuse me, with 3% F500 inside.
I need to run some sound. This way a little bit because it's almost full time.
Then you see that characteristic jetting flames, cyclical behavior. You're also going to see material ejection.
Please turn down the sound of the video.
Why we put it in a cage. Sorry, Hernán, what?
Turn you down the sound of the video, please.
Better? So we put it in a cage because of the material ejection hazard, and those little cells can fly everywhere. This is an F500 extinguisher, putting it about 2.5 gallons per minute. That typically an e-bike battery is no larger than 1 kilowatt hour. And we typically talk about 1 gallon per minute per kilowatt hour being sufficient. So we're significantly over that with this. So it puts it out fairly quickly. You have no more off-gassing, no reignition problem. Handles those small incidents pretty quickly. Notice the firefighters are wearing respiratory protection as well as fire protection. That's another discussion, but lithium-ion batteries do put off a lot of off gases that are immediately toxic. So you need to have that safety discussion if you're going to use them, use fire extinguishers at all, but especially in an industrial environment, you need to look at respiratory protection as well. So this incident we mentioned a little bit earlier. So Tuesday morning, really early in the morning, a truck carrying lithium-ion batteries met a truck carrying wood, and they sideswiped each other. They skipped off of each other. Lithium-ion batteries caught fire. Fire department brought F500, used about 5,500 gallons of water with F500 water additive, and we're able to put the fire out very quickly. As opposed to the one that occurred in July of 2024 in Nevada, took over 50,000 gallons of water when they were using plain water to try to extinguish it, and it took days. This one took a very short period of time, and they had it out. So F500 encapsulator agent isn't just tested by us. We have a lot of third-party testing for over 15 years by Johnson Controls, Kiwa, NIOSH, TU Clausthal University, Fraunhofer, Heinrich Hertz Institute, lots of different private firms for their own benefit have tested F500. We've never had a failed test on lithium-ion batteries as long as it was applied appropriately. And it's really pretty forgiving as long as you apply it in good volume. So this footage in 2021, F500 was used for lithium-ion battery suppression on this group of truck batteries. So these are 20.46 kilowatt hour batteries. You'll see there's 10 overall batteries there. Two of the batteries were involved. Each one contained about 96 cells, and we let it get into pretty good thermal runaway here, going proficiently, as well as thermal propagation from cell to cell. You see that cyclical behavior again here as cells start to ignite and then propagate from one to another. The battery was let to pre-burn for quite some time prior to extinguishment. We have stationary sprinkler systems securely fashioned 6 feet overhead. And once they triggered the extinguishing system, the battery goes quickly out. And for this experiment, they were only using a 2% solution of F500. We do recommend 3. That 2% went on, it darkened immediately down. There was no reignition, no continuance of any of the damage to the batteries. It was immediately stopped. All of these private industries are current users of F500. In the private industry, we like to work with companies that provide fire protection one-on-one, and we provide engineering support for both the F500 and the proportioning equipment that we carry. So the Diamond Doser is our premier volumetric water-driven proportioner, and kind of the neat thing about it is, if you look at the picture, it's placed into the riser. It turns a water motor. That water motor turns a small pump, which pumps in the agent at a very exacting amount into the riser, so you get a good wide range of flow with no variance in concentration. The concentration stays very, very stable throughout the wide range of the Diamond Doser. So we do fixed and mobile firefighting equipment as well. The Diamond Doser is just one of those. We also do bladder tank systems and round the pump proportioning systems and others. The Diamond Doser has proven to be a very robust and cost-effective device because it's not powered by any kind of electricity or external power. It's just the water movement that powers it. So even in a power outage situation, you're still going to get F500. So this video shows a system that's recently been developed and tested in Spain. So it was developed for parking garages and parking structures, and it features an F500 system along with a select number of deluge heads based on the size of the hazard, number of vehicles that are going to be parked there, kilowatt hours, etc. You're going to see that as soon as the vehicle begins to off gas and that detection is able to detect it, we can start that flow of F500 right away and begin cooling those batteries, as well as encapsulating those vapors before they turn into a hazard. once it does turn into a fire, and occasionally they pretty much instantly turn into a fire, the system detects it, the deluge is applied through the diamond doser. F500 is proportioned into the riser and fed to the deluge heads. And all of this can happen in mere seconds when it comes to lithium-ion batteries. They can go into a flaming thermal runaway very, very quickly. Or they can sit there off gas for an extended period of time. We don't have control of that. No one really does. But that even spray application across that entire zone that helps keep those gases down, cools the vehicle, confines it to the vehicle of origin, and maintains the egress path. And that's what the test showed. The test was successful, and now it's a certified system. It's certified by a company called Applus, which is a much larger company than even UL, and they do some reciprocal agreements with UL. Because of that, it was used in that system was used in Madrid, Spain, for their metropolitan transport bus system at their new terminal. So the diamond doser is very, very versatile. We design these with our engineered support and provide them to sprinkler contractors that are putting in sprinkler systems with F500. And then we come out and provide the commissioning and training and so forth that goes with the system to make sure that it's working appropriately. The nice thing about this too is you don't only use it for lithium-ion batteries, you also use it for three-dimensional flammable liquids, combustible metals, and a whole bunch of other hazards, even wood products. It's an uninterrupted system, so as long as there's concentrate available in a tank, in a tote, in a barrel that you can refill the tank or the tote, you've got that continuity of application. It can go on indefinitely. So it's a nice system, it's robust, and it's very wide-ranging. Has a very consistent application throughout the wide range, whether you've got a single sprinkler head open or all of them in a zone. It's going to perform flawlessly across that bandwidth. It's simple to install. It goes in a riser. If it's an existing riser, it's just a riser bypass. If it's a newly designed riser in a non-existing facility yet, we can design it right into the riser. So it's a pretty simple installation overall. It's efficient. We have small portable units available for firefighting use in the field and for industrial use. We also go all the way up to a 10-inch diameter diamond doser. And if that's not big enough, you can put them in tandem, like is in the picture there. The diamond dosers, the water-driven proportioners, we found lately as we're pricing out systems, creating proposals for companies, is they're generally less expensive than a bladder tank system of equivalent flow and capability. So the nice thing about that is they are very friendly to your bottom line. So a bladder tank has a certain lifespan to it, and then the bladder is probably going to go bad and it's going to need a lot of work. Then in annual testing, you'll lose a little bit of pressure and volume each time, so you've got to refill that. So you have some downtime for the system. You've also got the effluent that comes off of that you've got to, all right, now what do we do with that? With the diamond doser, you don't have to worry about any of that. You go up, turn a crank, and or you flow some water through it. You see how it comes out. You compare the concentrate to the amount of water that was ejected. You can even pour the concentrate back into the tank if you choose to. So very simple to maintain system with great total cost of ownership over the lifespan of the equipment. F500 is ecologically friendly. So again, that encapsulation starts from the beginning of the application, whether it's a sprinkler deluge system or whether firefighters are arriving. When F500 is going on, it's making those toxins, it neutralizes them through the encapsulation process. You're locking up volatile organic compounds and those things that would be harmful both to the environment and to people. A little comparison here before we end our presentation today, and that's foam, which we mentioned early on, that F500 is not foam. It doesn't fall under NFPA 11. It falls under NFPA 18A. To become an encapsulator agent, which there are several out there that are knockoffs and or claim to be encapsulator agents, but they can't meet this section 7.7, which is the defining criteria for an encapsulator agent under NFPA 18A. And section 7.7 shows that it actually does encapsulate in several different types of fuel or material that you need it to be tested for. So it's immediately effective to the agent that you want it to be effective for by the standard. Encapsulator agents have rapid heat reduction, foams do not. Significant toxin reduction, foams do not do that. Inert gases, number one, they're a poor heat reducer, but you also have to find a way to confine them in the environment. And then unfortunately, they're a threat to life in that environment. F500 is a benefit to life in the environment that it's proportioned into or sprinkled onto. And then water simply cools on a mechanical level, not a real efficient heat reducer, although we have a lot of it typically. We bring a lot of it with us as firefighters. We also have to apply a lot of it to remove heat. For 500, you'll have to apply a fraction of it. You look at that incident in Nevada yesterday. With F500, they had to apply 90% less water than they did with the plain water incident a month earlier. So big difference. Again, water does not reduce toxins. Inert gas increases toxins. Foam does nothing for toxins, but maybe add to it and add to your contamination cleanup costs. So with F500, you've got a significant toxin reduction because you're encapsulating a lot of that material, putting it in a format that is helpful and friendly for the microbes in the soil, for example, to eat it up, make it go away. So thank you for your patience in getting to this final slide. We'd love to see some of your questions now, if you've got them, and answer those if we can.
Yeah, we have a lot of questions, but let me allow to talk to Bobby. Bobby have some questions, maybe 6, but Bobby, you have the permission to unmute and make a comment or shoot your question.
Thank you, Hernan. Yeah, I'm dialing in from South Africa. I think you answered the first one. Thank you for that. The 15-year shelf life, where I asked about storage requirements. I think that was quite answered comprehensively. So just maybe a following question. Can F500 be integrated into existing fire suppression systems for our warehouses? So I represent quite a large logistics company called DP World. We've got quite a number of warehouses in the sub-Saharan Africa area. So yeah, maybe just to answer on that question, do I need to fit new infrastructure, or can I just plug and play, or how does it work?
Well, it's almost plug and play, but everything needs to have a good engineering look back to the hazard when we start. Make sure we're going to answer that hazard. So in a warehouse, we're typically talking about high ceiling warehouses, ESFR sprinkler heads that are 40 feet off the ground, and water has an inability to penetrate very lowly. F500 has an ability to penetrate deep down, and because of the high molecular weight, it does a pretty good job of reaching the floor very quickly without floating around or being carried away by convection currents. As far as retrofitting into a riser, yeah, it's a matter of a little bit of space and planning and engineering, and we can help you engineer a diamond doser typically into that riser or bank of risers. So that you're able to apply F500 with your normal sprinkler or deluge system.
Thanks, Dan. I don't know, Hernan, would you like me to read the rest of the questions?
I've
Yeah.
got them on my screen as well. I can. Hernan, you want to read the next one?
Yeah, I answered some of the question of Bobby, but one of the questions I did answer is, have F800 been endorsed by regulatory bodies in countries other than USA? The answer is yes. And we have Bureau Veritas in India. We have test report from the government of China. We have from the government of Germany. We test in labs in Argentina, in Brazil. Yes, we have different regulatory bodies in Panama, in Netherlands. We have, if you enter on our websites in the chronology, I put here in the chat in the website, you have the chronology, and in the chronology you have all the test report on all the approval of different bodies from different countries. The second question of Bob is, are there any available data to indicate the likelihood and frequency of lithium-ion battery fires?
There's an organization, Lithium-ion Battery Safety. They're pretty easy to find on LinkedIn, but they try to catalog and document all the lithium-ion fires from around the world. There's another company or a person here in the US that does that as well, and recycling fires, but they are growing, and it's not because necessarily it's the lithium-ion battery's fault. It's because lithium-ion batteries and people meet. And people do stupid things now and then with lithium-ion batteries, like discard them inappropriately, use them inappropriately, charge them inappropriately. If they're in a vehicle, the more vehicles we get on the road, the more that will crash together that have lithium-ion batteries. It's going to grow. It's a growing problem. Yeah. And right now, you know, in the EV world, at least, that problem is kind of a little bit on the lower side, but it's also the volume of EVs on the roadway is a little bit lower. So we're getting more and more of them every day.
We have other question of Bobby's, how does the F800 molecule of micelle not react to the H2O molecule in its predispensed state when containing the water for extinguisher?
Really good question. How does it not settle out and separate? I think that is kind of what you are asking. Because the F500 molecule is what we call an amphipathic molecule. It has a polar head and a nonpolar tail. That nonpolar tail is like the south pole of two magnets trying to be pushed together. You just can't get them together. So it's always trying to rush apart in the water so it stays self-diluting. And it's very water miscible as well. So it doesn't settle out. It doesn't collect on the bottom or on the top. It stays mixed.
Okay. Thanks, Dan. Thanks, Hernan.
Okay, I have other question from Paul Scheich. I tried to type. Does this work well for plastic packaging companies and plastic recyclers?
Yes, it does, and really all recyclers. We've been involved with helping the recycling industry out for several years now because of the ability of F500 to penetrate in between layers. And plastic's a little bit of a tough customer because plastic is a really good barrier, you know, but because of the organization of recycled plastics, the way they're layered, crushed, pushed together, there's also a lot of creases or open spaces in between them. There's nothing that's going to work better than F500 to penetrate that material. Plain water certainly does not. F500 is a much better coolant and penetrant of not only the plastics, but also the other ordinary combustibles that end up in a recycling facility on purpose or accidentally.
We have other question. We have other person that want to talk. Is Xiaoliang Guan made a question: what are the breakdown product of A500 in heat?
That's a really good question. So there was a study done in Laval, Canada, and that study looked at the toxins actually during interior firefighting. So they were looking to reduce cancer in the fire service in Laval, Canada. So they did a study with F500 alongside of plain water. So they did a series of burns with plain water, and then they reconducted those same burns as closely as they could get on the interior of an acquired structure with F500 at 1%. Well, with plain water, they were able to measure the results of the accumulation of contamination on the firefighters' protective hoods, as well as their helmet liners. They got a new hood and a new helmet liner for every attack. And then they were bagged up and sent to Ottawa University for testing. We have those tests readily available that show the plain water accumulation of contamination on the firefighters' hoods and how high it was, and the relative contamination on the firefighter's hood when 1% F500 was also used. And it was much lower across the board when F500 was used. And as a result of that, Laval, Canada switched to using F500 on every fire attack, not just on the special fires where they thought they needed it. And that's really one of the points that I like to try to get across in training or in webinars is that in order to save lives with the presence of really, really poor interior conditions, a lot of synthetics, lithium-ion batteries, combustible metals, and all the other hazards that we have to approach nowadays, when water flows, so should F500. And that's to save firefighters' lives and to be more effective at saving the public's lives. There's nothing more effective that comes out of a fire truck than F500 in water.
Okay, we have other. Xiaolin said, can you please send me a report of paper about the Canadian? Yeah, we have. Heather, please, you can put a report from our website here in the chat that the people can see this paper. We have other question, and we have a person that wants to talk. It's Enrique Reyes. Let me see if he speaks in Spanish. I can translate. Enrique, okay. You can unmute and you can ask some question. English or Spanish, I can translate. Enrique, you have to unmute first. O tienes que... Estás mudo, Enrique. Tienes que apretar para hablar. Okay, I don't know if Enrique can have access to the microphone. Okay, here in the chat, we put a report from Canadian, Charlene. I have other question before Enrique opened the microphone. Dan, does A500 biodegrade when it's in solution in booster tank?
No, we've tested it years later, and whether it's water mixed or by itself in a concentrate, it doesn't change over time. It's got a 15-year shelf life in the bucket. We don't have a determined shelf life once it's mixed with water, but it's years. We want you to use it on fires, however. If you're in a fire protection industry where you would maybe have the tank mix it for some reason, just talk to us and we can help you through that and make sure that you're using it in a compatible way.
Okay, thank you. Roberto Guerra from Peru is an engineer on I know the guy, but he said, I think the use of diamond doser is the best way to distribute water with F800 EA for property protection, parking garage, homes, ships. For EV problem, we should have a remote command with a tank pressurized with F800 inside the car or vehicle to wash the battery compartment. Do you agree?
To a point, I do. You know, it's going to take some engineering to include a pressurized F500 system inside of the smaller vehicles, especially. That could be a little bit of a challenge. However, especially on the larger heavy equipment, that's very, very possible. And we're developing those systems now. It's a matter of getting our technology up, getting it tested, getting it approved, and then working with the manufacturer of those vehicles to make sure that they're putting it in place appropriately.
Yeah, the only problem is that the factory of the cars, they don't want to say that their cars can burn.
Right, yeah,
it's not very good for marketing. That's, you can buy a car that you can burn. It's not very good for marketing. But
right.
Believe me, I received an inquiry to use our product inside of equipment that they want to put on the lithium battery that you can connect front of side, or you have a connection that you can. But it's moving the market. I believe that we have the last question. I tried to answer some question, Dan. Let me see, because I remember one of the guy, somebody asked if F800 has UL approved, and I answered that yes. David asked if F800 using manufacturing. He commented that they have multiple AGVs, automatic guide vehicle transporting equipment through our facility. And we say yes. We have Honda here in Mississippi, no, Alabama. They are using our product. They have different equipment that they move different cars. And Michelin in Mexico, they are using inside a warehouse to move with robots different tires. I don't understand this question, but it's from Jose Babilonia. Dan is, so battery not in the factory location, is it the same capacity, only 13 kilowatts hour? I don't know if you understand the question. It's in the chat.
Is it in the? It's in the chat.
Yes.
And who was it from again?
So battery in, I believe that is not in the factory location. Oh, is it in the same capacity? I don't understand. This is why I didn't answer. I don't know, Jose, if you want to open your microphone and read this question.
I'm looking at the chat now too to see if I can find it.
Too. I don't understand the question. It's a pain. Okay, Dan. We have 2 minutes. If somebody wants to put in the chat for question or an answer, or here in our chat, if somebody wants to clarify any of the answers, please put now. And if you are okay with all the answers, we invite you to visit our website that you can have a lot of information. You have a blog, you have different brochures that you can download. And when we finish, maybe this week or the beginning of the next week, we will send you an email with this link of the YouTube channel that you can see again this video with this presentation and some additional information. And we try to put in the email your local contact that you can be in contact with them and try to make a demo, understand better, or contact me by email, and we can create some bridge between your local people in any part of the world or here in USA. Dan, it's your time to say goodbye to everybody, and I believe for today we are done.
Okay, goodbye, everyone. Thank you again for joining us. As Hernan said, here in the US, we have reps in every part of the country, but we have distributors all over the world. So there's a way to get a hold of us. The easiest way to start is at our website.
Okay, thank you again, and have a good day, good afternoon, good night, and we are see you in the next webinar. Thank you, Dan, for your patience.
Everybody.
Bye, everybody.